Alright folks, so hopefully this video can answer any questions you have. We are going to be answering them in class today, but suppose you're doing your problem at 11 o'clock at night one night, and you're like, oh, I have a question. The object of this video is to help you, because I am not responding to emails at 11 o'clock at night. I'm assuming you've read this first page already. If you haven't read this first page, you should probably pause the video and do so, because we're going to be referencing it a lot. You need to have read it. We're going to start with the questions. Those start on the second page. A. How much will Pamela have in her retirement account when she is 30 years old? So all that information that you need is up here. Pamela gets her $2,000 a year bonus and she deposits it into her retirement account at 9% every year. At age 30, after her 11th bonus, she decides, well, I've saved a lot, I'm just going to go travel the world. So she has $2,000 a year, 9% annually, and she has 11 checks. That's a geometric series, and you have a geometric series formula. I suggest you use it. Question B. How much will Candace have in her retirement account when she is 30 years old? Well, let's look back at the first page. Candace spends from 20 to 30 traveling the world and enjoying her bonus. Cool, good for her. Then on her 30th birthday, she's like, oh, I should probably save some money for retirement. So she decides to stop traveling the world with that money and starts putting into a retirement account on her 30th birthday. So you're just answering how much she has in her retirement account on her 30th birthday. This one, no math involved, just critical reading skills. C. So Pamela makes no more contributions to her retirement accounts after the 11th bonus. The total amount in her retirement account can't be found using the same geometric series in part A. Explain why. Hint, think about what changed. Think about the activities Pamela was doing before her 30th birthday and what she's now doing. Let's look at D. Candace makes annual contributions to her retirement account, starting with her 11th bonus. Remember, she's just putting those $2,000 in every time. Explain why the total in her retirement account may be found using a geometric series. Maybe look back and see what's happening to that geometric series. E. So now we're talking about Candace. Candace's retirement account grows by a geometric series. How much will Candace have in her retirement account when she turns 65? So remember, Candace is the one who started at 30. So she has the $2,000 from her 30th birthday, then her 31st, her 32nd, her 33rd, her 63rd, 64th, 65th. Count up how many you got. Remember, it has to start at 2,000. That's the first one she plugged into her account. And hey, if this grows by a geometric series, you have a formula for it. And all the information is given. Now, Pamela's retirement account grows by simple interest. Now, you've seen simple interest before in Algebra 1, but it might have been a while. It's given by this formula. All right. A is the final amount, so that's what you're going to be solving for. P is the principal amount. Hey, you know how much she has in her retirement account at 30. Plug it in. R is the percent rate of change, and I even give that to you. And T is time in years. Well, you can figure that part out. Plug it into this formula, and you're good to go. Find out how much you will have when she turns 65. In G, I'm asking you to compare the two sisters' retirement account totals. Were you surprised by what happened? I mean, Pamela contributed for 10 years, Candace retired. Pamela contributed for 10 years and then just let it grow on its own. Candace contributed from the time she was 30 to the time she was 65. That's a lot longer. Were you surprised by the result that happened? And then, why do you think that result happened? If you just answer this with, no, I was not, you will get no credit. Same as if you answer with, yes, I was. No credit. You need to say why you think the result happened. So, last one. Suppose Candace spoke with a financial advisor on her 30th birthday before contributing anything to retirement. So her retirement account still has zero. She might have her $2,000 check in her hand. And she's like, what do I want to do? So suppose the financial advisor said Candace would have to put more money into her retirement account each year to have the same amount in her retirement account at 65 as Pamela does. So how much would Candace have to contribute monthly to have the same amount at retirement as Pamela? Show all the work. Well, this is going to be very similar to E. The only thing that's going to change is you're going to have to find the total amount that Pamela had and set your equation equal to it. And you're going to not have an A1 value. You're going to solve for it. Your equation might look wonky. I highly recommend A, plug in all the values you have, leaving A1 as just the variable A1. B, simplify everything on the right-hand side, so that way you just have a number next to A1. And then C, solve by inverse operations. I really hope this video helped. I wish you the best of luck, folks, and if you have any other questions, see me in office hours. Have a good one.